That's okay. That's what.
Hey everyone, thanks for joining us. We'll get started here in just a couple minutes. We'll give people some time to hop on. Can anyone who is on, can someone do me a favor and put a question in to the question and answer, and I'm going to see if it pops up for me. I guess actually OHD video conference, you could do that for me. Well, no, because you're part of the hosting team. Maybe not.
Stephanie, Frederick put one in. Can you see it?
Nope. I do not know why. I just sent you a
Okay.
picture of my screen and like my questions is gone.
That's okay. I can see it and I will manage this. It'll be like we're
Oh,
in the
weird.
same room
Did
like
you
other
just open it?
times. Yeah.
It just popped up on my screen. So now I have it.
Wow.
Okay.
Oh, great.
Thank you, Frederick.
Thank you, Frederick.
It's covering up a large portion of the screen, but that's okay. Okay, we're going to get started in just a minute. We're going to go just one more minute and let people hop on. I hope everyone's having a really good Safe+Sound week. I wonder if anyone is also someone who joined us yesterday. Okay, I've got 202. I'm going to get started. Is that okay with you? So Laura, our marketing manager, is helping me stay on track, but she's the OHD video conference. So I'm Stephanie Lynch. I am the Senior Technology and Research Manager at OHD. And this is, I think, and I just said this yesterday, I think it's our 5th year participating in Safe+Sound. And one thing we really love to do is give these webinars. OHD is out of Birmingham, Alabama, and we manufacture and sell industrial hygiene instrumentation. And we are the proud US distributor of Svantech noise monitoring equipment. And so today we're going to talk about some of those noise monitoring basics. And please do feel free. It'll actually help me. Yesterday, I didn't say this, and I ended up just flying through my respirator fit testing presentation. But so if you have a question, please drop it in that question and answer, and I should be able to see it live. And if not, Laura will help me, and I'll ask every now and then if there are any questions, if my access seems to go away or it's blocking my screen too much. Because I'm currently traveling. I'm working in Little Rock, Arkansas, and so I'm having to work off a laptop, which does make things a little bit more challenging. Okay, moving on to some noise monitoring basics. You can also just drop in any interesting facts you have if you just want to give me something. Also, anything that could help me learn something today, because I love when I get the chance to learn something. Okay, I am going to have to move a couple things to get to where I can see. So why do we want to monitor our noises, right? Why do we care? So of course, first and foremost, we care because we care about our employees. We don't want them to go home and have hearing damage and not be able to hear their family members. I remember my grandmother, RIP. She got older, probably 70 and up. She did live a long life, but we would be having these family gatherings and she's sitting there smiling, but she was completely disconnected because she couldn't hear anything we were saying. And just every now and then she would kind of drop in a comment. But I just remember thinking that was terribly sad that she couldn't fully participate in this family that, she was the matriarch of. And I think it was Helen Keller famously said that her blindness was what separated her from things, but it was her her being deaf that separated her from other people. And I think that's that's why we care. Another thing is for job satisfaction. Even if you don't have a damaging level of noise, having a continuous noise or a noise even intermittent, especially if there's awkward amounts of spaces, can really impact job satisfaction. It can be very annoying. It can be very fatiguing. For some people, it can even cause things like gastrointestinal disruptions. And I don't even know if we're 100% sure why that does happen. Another thing is for maintenance. A lot of times, if you're not performing proper preventative maintenance on your equipment, you can start to have something get loose, and it can lead to increased vibration, and that can end up increasing the noise levels. And then, of course, and it's a little bit unfortunate how important this part is, but compliance. So we're obligated to monitor our noise once we get above the OSHA action limit here in the US. And so for that compliance, you're going to need to perform noise monitoring. And so that action limit is 85 decibels. And we're going to talk, of course, a lot more about that as we roll through the presentation. So first off, let's just make sure we're all on the same page. So what is sound versus what is noise? And a lot of people say that noise is just unwanted sound, but I like to look at it a little bit deeper than that, which is where sound is objective and physical, and noise is subjective and psychological. Meaning that old adage, I guess, where if a tree were to fall in the woods and no one was around to hear it, would it still make a sound noise? And in my opinion, it's still going to make the sound, right? That's an objective physical thing. But if no one's there to hear it, then it's not a noise. It's not going to be bothering anyone. It's not going to be that thing that we're concerned about, that unwanted sound. And this is just showing it, a little bit more scientifically as we talk about, our sounds moving through the air. They do need something to travel through. So it's going to move through, and then when it becomes noise is when we perceive it. So sound is that objective physical thing moving through the air. And when a receiver gets that sound, that's when it can become noise. And typically we look at it for either being, harmful or annoying. And then just a little bit of background on anatomy of how we're actually hearing. So we've got sound waves that enter our ear. They vibrate our eardrum. They vibrate those middle ear bones. And then they go on to that oval window, which is going to cause a movement of some fluid in our little cochlea that looks like a snail shape. And that's going to do all sorts of things. But one of the main things we think about is those cilia that are floating around in that liquid, in that fluid. And when those get damaged, they're not able to repair themselves. But so when they're not damaged and they're all fully functioning, they do all sorts of things to where we get to hear all these different, this wide range of sounds. So that's what's happening essentially in there. Just a little bit of not very technical anatomy. So there are different types of noise. There's continuous noise. There's variable noise, which is going to have some variability in its intensity, specifically with durations of over a second. Continuous noise is going to be something that for at least a second is constant, but it's really what we think of as that sort of, constant noise, continuous exposure that can actually come from a multitude of sources, and usually does. And then impulsive is actually one of the harder ones to characterize. It's actually kind of a emerging issue in noise where it's not well characterized by the instrumentation that we currently use. So, and it's not fully understood how bad the damage is for a hearer. So I just got to participate in a really cool PDC at AIHA Connect that was on the impulse noise from gunfire. And it was really cool to just see how there is stuff out there that is able to capture that, but how we need to do better in characterizing it and protecting against it. So that's that noise of less than 1 second, our impulsive noise. Sorry, I'm each time like having a little trouble flipping slides. You'd think after years of doing these presentations, I would be better, but I'm not. Okay, so there are a lot of terms in sound. So with our period, that's going to be the frequency. So how many cycles are going to occur within a second, and that's going to be described in hertz. So hertz just means per second, 1 per second or 2 per second, whatever it is. And then amplitude is going to be the intensity. How far it gets away from center is going to be how loud the sound wave is. And unfortunately, with noise terminology, there's even more that goes into it. So we measure sound when we talk about when we talk about noise or sounds, we're talking about it in decibels. And that's going to be on a logarithmic scale. And we're really doing that just to make it easier to talk about noise, because it's just an immense range. So we take whatever measured sound intensity, I'm not sure if y'all can see my mouse, but whatever measured sound intensity, and we're putting it over the reference sound intensity. So that's the threshold of human hearing, which, as you can see right here, is a very, very small number. So we're putting it over that to get that smaller number to be able to just talk about it. But because it's on that logarithmic scale, it's not like we can just add them together or use them how we would normally use just normal numbers, because they're on that logarithmic scale. But so it makes it where we can talk about it. 82 decibels sounds a lot better than if you talked about 82 million, whatever. So it just makes it where it's much easier to talk about. Okay, so we talk in decibels. Then we talk about frequency. That's measured in those cycles per second. And anything like per second, I just talked about, that's going to be in hertz. Sometimes you can also see kilohertz. And so most times, the best way to kind of describe how we hear our noises is when something's a very high pitched. Can y'all hear that? Ooh, did you get that, Laura? Because I got it. So the higher frequencies are going to sound very screechy to us. They're going to get the much higher pitch, and then low pitches are going to be very bass-like. So can y'all hear that? That's 250 hertz as compared to the 10,000 hertz. And if anyone does want to drop in the chat if they can hear it or not, because I have a few more of those and I don't want to waste my time hitting them if you can't. So one important aspect of noise monitoring when we talk about frequency is frequency weighting. So there are 3 ways to, well, actually, I think there is a fourth that we don't even talk about. I think there is B weighting, but I'm not familiar with it. So A weighting is when we talk about, we know where human hearing is most sensitive, between that 500 and 4,000 hertz. And so we get an increased sensitivity in that range. So outside of that range, either below the 500 hertz or above the 4,000, an A filter is going to reduce its sensitivity, and that's going to mimic how that human ear would respond. C filter is going to be a more linear way of measuring the sound, and it's going to put emphasis on those lower frequency sounds. And this can be used for assessing issues with machinery. I mentioned at the beginning how certain ways of measuring sound can help you identify maintenance issues. And then also for community noise applications, because when we look at community noise, we're not necessarily just concerned with the humans. We can be concerned with the environment, how it might be affecting certain animals, whatever. And then Z weighting, I've always called that just zero weighting, but it's going to be linear with zero weighting. And again, do feel free to just put in some questions. I don't know what that was. Okay. So with that A weighting curve, these are those other sounds that I have that hopefully are going to play. Maybe not. Don't know if y'all can hear that, but that's a pure 100 hertz sound. So it's very low. And then we're going to go up to that 250. That's the one we just heard before. Then 440. You can see that one. That one to me is like distinctively higher pitch. Then getting much, and then now we're into so that was that 1,000 hertz, and this is that 10,000 hertz that we heard before. So you can see how we're perceiving that uh, is different from how it's actually, so that those all have the same pressure level, but how we perceive it is very different. And that's why we have to put things on that A weighting scale, because of how the human ear is actually hearing it. So we have different ways of measuring sound. We're going to start by talking about sound level meters. So sound level meters are used typically for area monitoring. So we can evaluate noise levels either for the environment, for the community, maybe to do a noise map. I'm currently using a sound level meter, Svantech, of course, my 973, to I'm here in Little Rock at a warehousing operation where we're installing sound absorbing curtains to lower. This facility was kind of right on that brink of the action limit. And as opposed to trying to develop a hearing conservation program for their entire site, which is quite large, they've decided to invest in sound curtains, which are going to lower the exposures below that action limit. So they're not going to have to implement that hearing conservation program. So that's a perfectly appropriate use of a sound level meter. It can also be to help you select, I mentioned that noise mapping, but so that you're able to select appropriate hearing protection so that you're able to protect your employees without overprotecting your employees. That's actually a concern because you don't want to make it where they can't communicate or aren't able to hear things like a safety alarm. And then what I just talked about with the sound absorbing curtains is an example of something you might choose for noise dampening. But there are tons of other types of noise dampening materials that you could use. You know, I'm sure you've seen different panels and stuff that you can put to dampen some of the noise. Ooh, sorry, went too fast. So there are two classes of sound level meter, and your regulation might tell you to use one versus another. So class one is going to be for certain precision uses. I would say if you're having to do anything that you anticipate becoming a legal issue, you're probably going to want to lean class one. Whereas if you just need to go out and kind of do some noise monitoring and get an idea of where you're at, but it does need to be, you know, for official purposes and within a certain classification, most regulations are going to require that class two. And then of course now we have some other ways of just maybe identifying if you have an issue where you need to go invest in noise monitoring equipment like apps on our phone that can just kind of help us identify if we are close. Now those aren't going to get you, you know, this good, but they will definitely identify if you have a problem and need to go invest before you go invest in this kind of equipment, right? So something good to look out. I think NIOSH has one. Okay, octave bands are not typically, yes, Bess, we will definitely send out these slides. So octave bands are not necessarily something you're going to use for compliance, but they are really cool for helping you characterize your noise. I was talking about installing these sound absorbing curtains. So what you had to do before these curtains were designed or selected, these were designed, but specifically for the sound, they had to characterize the sound. And one thing that they did was get very in depth into these octave bands and into the frequencies of this sound so that they could design curtains that would specifically absorb the levels that they were concerned about that were most applicable to human harm, I guess. So human hearing. So one thing about octave bands is that the highest frequency is twice the lowest frequency. If you ever need to get into that, you can go further. But so for instance, 1-to-1 is sort of the minimum you would do for octave bands, but that's less descriptive than 1/3 octave bands. And that's on the next, I think it's one more slide from here, but 1-to-1 is less descriptive than 1-to-3, and it goes all the way, at least with Svantech, goes all the way to 1/112 for the octave bands. So you can get really in depth into your noise if you need to with Svantech equipment and software, and probably with any brand. You know, that's what I use, and that's what we sell. So some of the benefits of octave band analysis, like I mentioned, are going to be able to look at what's coming in from your sound and maybe help you identify what about the noise, like which frequency band is of concern. And if you're able to then sort of target that as far as protection or whatever else, it can help you just kind of dig into your noise a little bit deeper. Like I said, not exactly a huge thing with compliance, but if you are noticing something with your noise and you maybe already have noise monitoring equipment, you would be able to get more information about that noise to maybe identify what the problem is. So for instance, if it does end up being, a lower frequency that's the problem, the only way you'd be able to identify that that is the case is with octave band analysis. So I mentioned 1-to-1, a little bit less descriptive than the 1/3, and that it can go all the way at least to 1/12. If that's what Svantech does, there might be something else. Okay, some of the very important aspects of, my slides just went crazy. Some of the very important aspects of doing your noise survey, something you might do with a sound level meter, are location, location, location. So you want to make sure that you're putting your sound level meter away from your body and at a height that's reasonable to consider people's ears, being at, right? Don't place your body in the way, and also don't make it where your body might cause a problem for like reflection. Do not place your meter on a machine or anything that's vibrating. And then I can't emphasize enough that you want to do pre and post calibration. That is one thing that can be incredibly frustrating with a lot of industrial hygiene monitoring, but you really want to make sure that you get that pre and post calibration. It's maybe slightly less important with area monitoring, but it's still really critical because you are going to see some drift. This equipment is so sensitive that you will end up seeing even just like a little bit of drift. And if you are on the edge somewhere, especially of that action limit, that's going to be very important. So noise dosimeters are just a very specialized sound level meter. And they're called dosimeters because they're going to measure dose, which is something we're going to talk about. So noise dose. They're for personal monitoring, which is what you're going to end up having to do if you are in a hearing conservation program, you're already over the action limit, you're having to implement this, then you're going to need to show people's personal noise dose. Now, all the dosimeters you're going to be able to get are going to be light. They're going to be unobtrusive. They'll sit on your shoulder and clamp up there, and most people it doesn't bother them at all. Now, uh, other things about it, I guess, yes, bother them about it, but we'll get into that too when we talk about some of the pitfalls of doing personal voice monitoring. So a lot of things make it where you might need to do personal monitoring as opposed to area monitoring. So a lot of things like if your workers are moving around a lot and they're getting a lot of different noise exposures, you're going to want to maybe characterize their personal noise. If you're having significant variability, within the job, then you might need to do personal monitoring. And then one thing that we just talked about was impulse noise. Even a noise dosimeter, it's not going to be able to fully characterize that noise, but you still want to be able to capture. So the benefits of doing this are that it's going to help you be compliant, but it's going to allow for you to really get an individual's, full assessment. You'll be able to characterize their noise exposure, and it's going to be individual to them. Well, you can create groups that have similar exposures, and that's going to help you maybe only have to do a few people as opposed to a whole group if you do have people who are doing the same thing, but that's going to depend on your operation. And it is going to allow you to monitor for that full shift, and you can do all sorts of things with these monitors, with these dosimeters, where you can set it to go at at shift start. You can set it to take the appropriate break times if that's applicable. There's all sorts of things you can do with these instruments, and we'll talk a little bit about that. Okay, so noise dose, that's what these dosimeters are specifically measuring for compliance, is a percentage of what you're allowed to be exposed to. And that's going to be 100% based on the regulation you're following. So here, our bare minimum that we need to follow is OSHA. And we're going to jump into what that is compared to some other options that are a little bit more protective and why we might do that. So that's combining the intensity of the noise with the amount of time that you're exposed to that. And the dose is going to be whatever time you've spent at a specific sound level over whatever time, based on the standard you're following, that you're allowed to be at that sound level. 8 hours of exposure at whatever exposure limit is going to be that 100% noise dose. And so that's something important to take into consideration if your guys are working a shift outside of 8 hours. So like currently the operation I'm at is a 12-hour, it's a 24-hour operation, but their shifts are 12-hour shifts. So we have to look at that exposure differently and adjust for that. So that's something you should be made aware of. So this is one example of how you're going to see the differences between this is NIOSH versus OSHA. So NIOSH has recommended exposure limits. And you can see that based on their, I'm not sure if you haven't seen my mouse, but based on their 8-hour allowance, you would be allowed to be exposed to 85 decibels on an A-weighted scale for 8 hours. And then OSHA is going to allow you 90 decibels on an A-weighted scale for the 8 hours. But you can see that very quickly, as that noise level goes up, that's very quickly going to become a pretty big discrepancy, right? And that's because the biggest difference between these two exposure limits is that NIOSH has an exchange rate or doubling rate of 3, whereas OSHA follows an exchange rate of 5. Now, the way that sound behaves is the 3. So that is a better and more accurate and more protective way to follow. But OSHA's is the bare minimum. That is what you can technically expose your employees to. That doesn't mean you should. And I have other things I can get into about that, but that's just something to know. So as OSHA is going up and saying you've got 5 more decibels of exposure, then that cuts that time in half. So you go from 8 hours to 4 hours. And with NIOSH, it's every 3 decibels that you go up. So you can see by the time you get down to 15 minutes, it's a difference of that ceiling level being the 115 of 15 minutes or 100. And so you can see how they just start to get further apart. So one thing that any dosimeter is going to allow you to do is measure all of these things. So you can measure the OSHA PEL, permissible exposure limit. You can measure the OSHA hearing conservation requirements, and you can measure the NIOSH, which is also the same as ACGIH. And you can measure all of those at the same time. So it's going to have multiple channels that are doing different things. And you're going to get to see the report on all of that. So you're going to be able to, show compliance with OSHA, and then go above and beyond. If you're in a hearing conservation program, you can go ahead and apply, NIOSH limits. So that 3 decibel exchange rate, a lower threshold. That's something I don't think I've mentioned yet. So OSHA, any noise that's above that 90 is not counted towards your dose or your employee's dose. Whereas with OSHA hearing conservation and NIOSH, those channels, it's going to count anything above 80 decibels. That's that threshold for that noise. So hopefully all of that's making sense. So one reason that you should consider applying one of these other more conservative values for noise exposure for your employees is because it's sort of been shown that at 90, this is with research over, I think, a pretty long period of time, but with a time-weighted average of 90 decibels over an A-weighted scale of exposure, there was an excess risk of hearing loss of 25%. If you lowered that down to 85 decibels over the time-weighted average, so over their 8-hour shift over a long time, the excess risk of hearing loss was only 8%. And if you could get that all the way down to 80, then you saw only 1% of excess risk. So that's a huge difference as far as the protective nature of your regulations. And then that's with noise below the 90 dBA, talking about here, averaged as 0, which I mentioned on the last slide. So this is going back to a couple of the different concepts. I mentioned how noise is measured on that logarithmic scale called decibels, but they don't add together the way that you could just add, 2 plus 2 equals 2. It doesn't work that way. And the way that it is from a regulatory standpoint, I just talked about, which is based on that exchange rate, which is the doubling rate. So as you go up by 3 decibels for NIOSH and ACGIH, you're doubling that noise exposure, and therefore you're having the time halving the time that the person is allowed to spend at that level. So 85 plus 85 only equals 88. So that's that 3 decibel exchange rate. Like I mentioned, that is more accurate. That's how sound behaves. But for OSHA, they're going to use the 5 decibels. One quick thing, if you're ever, if you already have your CSP or your CIH, one thing that you'll want to know is this chart. So as the noise levels of whatever things you have at your facility, so any 2 things that are giving off different noise level, if the difference between those things is 1 decibel, then you have to add that 3 decibels. So if it's 0, if they're exactly the same, then you're adding that 3 decibel. If it's, one thing different, you're adding that 3 decibels. If it's 2 to 4 decibels, then you're only adding 2 decibels. So if it had been, 85 plus another piece of equipment that was doing 87, then you would only make it 89. You're only adding the 2 decibels to the highest one. And that just goes up all the way to 10 decibels, where once there's 10 decibels of difference, you're not adding anything. So if it had been 85 plus 95, it's just 95. That's 95 decibels of exposure. And of course, it gets much more complicated. Most noise that we're exposed to is not this simplistic, right? It's not one machine plus one machine, but just so you get the idea of how we're doing it. Another important thing, if you're going to be doing any noise monitoring, is understanding the difference between the L equivalent, so LEQ, which is that equivalent continuous sound level with that 3 decibel exchange rate, because that is how sound actually behaves, versus the L average, which you're going to see, which is the time averaged sound level with an exchange rate other than the 3 decibels. So like OSHA's 5 dBA. That's just an important note, because you will see both of those values or one or the other depending on your sound level meter. So your time weighted average, that's going to be based on OSHA. So that's going to be based on that 5 decibel exchange rate. And it's going to be based on the total amount of workplace noise that your people are exposed to. And it's going to be expressed as an equivalent standard 8-hour day. This is what OSHA is using. So they're taking all of the noise that your employee is exposed to over that 8-hour period, and they're averaging it down using that 5 decibel exchange rate. Okay, if you go out and do personal dosimetry, one of the things that you definitely want to do is make sure that your batteries are charged. I love my Svantech dosimeter because it has a rechargeable battery that I just place on its charger, and I can pretty much ensure that it's ready to rock and roll. Whereas there are others where you're going to have to use a battery. You do want to make sure that you've got spare batteries, and just always have extras with you. Calibrate, pre and post, same thing. Make sure you talk to the employees, preferably well beforehand, about what you're going to be doing. I mentioned that, most employees don't really find them obtrusive, but there are a lot of employees who might think that you're recording them to listen to what they're saying. I've seen people sit there and talk into it as though I was somehow able to actively listen to them continuously. Anyway, so you do want to make sure you communicate about the benefits. Make sure they understand things like, if you go out to your car on a break and turn the radio up really loud, that's not the noise we're trying to characterize. That's something that you're doing on your time. But if you have your radio playing at your workstation and that's something that's allowed and that's something you're doing every day, then that is part of your exposure. And that may be something we need to discuss or look at. So you're going to place the dosimeter, make sure that it's as close, that microphone is up as close to the hearing zone as possible, and start your measurement. And then you just want to leave it alone. And that's one important thing about having the windscreen in place. So that windscreen, it's actually not, it shouldn't be called a windscreen, because yes, it will help protect against some of the wind, but it's really like an interference screen. So you want to have that to keep someone's collar from brushing it and it giving a false reading, someone's beard hair or hair, whatever. Uh, and then let those people work. Make sure you are coming by regularly to check to make sure it is still running. A lot of them now will have a notification, a way of seeing from a distance that you're having some issue, and observe what the people are doing. Right. Then you're going to stop that measurement. You're going to remove that dosimeter, and you're going to post calibrate that instrument, and then you're going to be able to get into as much or as little as you want in the software to kind of evaluate that noise exposure. So if you want, or if it's necessary because you get readings that don't really make sense, there's only so much you can observe, you're going to want to go in there and look at some of your high levels and maybe evaluate if that was work related. I have had where I can't keep eyes on 10 people at once. And I have had where people have gone out to their car and listened to the radio and turned it up. I have had the people yell into their monitor. It's unfortunate, but it does happen. So Svantech will identify some things that it thinks are Svantech Supervisor software. There's a advanced one called Supervisor. There's also Supervisor Lite if you're sort of less, you don't want to get so much heavy noise knowledge or functionality, which I actually, for the record, I'm probably a pretty advanced noise person, but I prefer the Supervisor Lite. But you can go in there and see those events and identify if they are work related, or identify what they are if there's something of concern, right? Like you identify a particular noise, you're hearing it intermittently. You can go listen to that audio recording and you'll be able to identify that noise better. This is just showing where I took a quick measurement with my monitor and was able to see, this is the specifically ACGIH standard that I was following. It's going to tell you the information about that standard. So your exchange rate of 3 decibels, the criterion level of 85, and your threshold level of 80. And I just did a real quick measurement. But so if you went through and looked, you could see that the person had only a 1.8% dose, so forth and so on. You kind of get the idea. But you can do that for each of your channels. So some of the common survey pitfalls, if you go out and you're the one responsible for doing this noise monitoring, is dosimeter placement. So if you do place it too close to someone's collar and that collar is just constantly hitting that windscreen, you might see something. Employee interference, I just mentioned some of the ways that employees might interfere. You can have some inaccurate assumptions about your noise or about your just your facility in general. Another thing is threshold distortion. So you can get lower values if you're having a lot of noise that is hovering right around that threshold value. So 80 for the ACGIH or NIOSH, or the 90 range for OSHA. Wind, even with the windscreen, if you're getting a lot of wind, it can end up interfering with your noise measurements. And then I mentioned how important it is to do the battery, and then also people calibrate your instrumentation. Pre-calibration, post-calibration, you will see some drift no matter the instrument you're using, and you just want to make sure that you're accounting for that appropriately with your measurement process. So after all that, we're what are the benefits of doing this noise monitoring? I already, talked about how important it is to hopefully characterize your noise so that you're able to implement some controls, right? Whether that is appropriate hearing protection devices, or hopefully you're actually implementing a higher level of control. With industrial hygiene, we always want to start at the very top, which is actually eliminating the noise exposure entirely. I recognize feasibility is an issue here. Then maybe substituting. Is there something in the process we can do to substitute for something that makes less noise? Then we get into engineering controls. One example of that could be these sound absorbing curtains, but there's a lot of ways to engineer out noise. Of course, it's best if you can be a part of the design process and actually, lower the noise on the front end. I will say that what this warehouse facility is doing is a very expensive afterthought. Very expensive afterthought. Whereas if they had thought about things beforehand. So, for instance, they use very hard plastic totes. Well, hard plastic totes, as they're doing essentially anything, make a lot of noise. If they had, chosen a different material, they could have lowered that a lot. If they had slowed things down, if they had changed there's just so many things they could have done. They could have enclosed a lot of other things. I don't want to get too deep into it, but of course, if you can do stuff in the design phase, you're going to help yourself a lot. So you want to have your people where they're able to, feel good about their job. So they're going to be more productive. They're going to be able to communicate better if noise levels are low, or, if you do have noise, then if you have the appropriate amount of protection as opposed to overprotecting, then people should be able to communicate. And then another benefit is if you're doing, if you're a big site and you need to keep quiet because of the community, even if you were there first. I used to work for a steel mill, and when the steel mill was built up, it was the only thing in this area. But years and years later, now there's a whole community around it, and they're a 24-hour operation. So they needed to do stuff. They had to implement a lot of different kinds of controls following that hierarchy to get that noise level down for the community so that they were still able to run that 24-hour operation. And they did do it, and they did a great job. So those are a lot of the benefits of noise monitoring. Another thing is just I kind of talked about it at the beginning with my grandmother and Helen Keller, but you're going to feel so much better if you are able to hear as you get older, and also if you're just not exposed to that noise on your job. It's going to improve your mental health. It can help your memory stay good. You can, if you're still able to connect with people in that way, you're going to be less likely to be depressed. It can apparently lower your chances of getting dementia. And yeah, just a lot of improved health benefits. And this should be sourced, but I'm feeling like I don't see a source on there. I will share that source with that email when we share the slides, because these are both just taken from another group that I'm struggling to remember now. But it's important to know that this really is kind of you would think by now that maybe we would have gotten better, but nearly 50% of Americans who are over age 75 suffer from some amount of hearing loss. There are 1.4 million children, and I hear that number is growing, and that it's also getting larger in the range from 18 to 25. And a lot of people think that that's because of the earbuds that everyone's wearing. If you do have hearing loss, a lot of people end up waiting like a really long time to go get that addressed. 1 in 6 people between the ages of 41 and 59 have a hearing problem. 48 million Americans, or 20%, have some degree of hearing loss. 3 in 10 people over 60. I mean, you can just see that this is not a small problem. This is impacting a lot of people. And unfortunately, I don't really have any reason to believe that it's going to lower anytime soon. Another one is the tinnitus, or some people say it a little bit different, but yeah, we'll just stick with tinnitus, which is that ringing in your ears. I know a lot of people who are in the military who suffer from that. And I imagine a lot of it is because of noise exposure, maybe a lot of that impulse noise, right? And sorry, my husband was in the Army, and I used to work for the Department of the Army. Okay. Wow, that was a lot of talking. Does anyone have any questions? I really hope you do, and I hope that you learned something. I appreciate everyone being here. And I think I can see the questions, so if I don't get anything here in just a second, then you're released. Okay, Laura, that's all I got.
Great job. Thanks, everybody. Stephanie, you want to fast forward to the next slide real quick just to show
Oh,
everyone where they can find you
oh,
if they have
hi.
any questions?
That's a good point. Sorry, now I
There
see.
you are. Awesome. Thanks, everybody, for attending. We'll send this out, the recording and the slides out this week. And if you need anything, you can find Stephanie, or you can visit our website. Thanks so much.
Thanks, everybody. Bye.